Hello everyone, I'm Philip and I will walk you through my poster. So, in this study we were interested whether the tracking of several objects were the same when we use 1 over f background and the objects were Gabor patches. So we did 2 experiments in which we explored this paradigm, and then we did 2 additional follow-up analyses in which we studied differences between subjects and between trajectories. So if you don't know multiple object tracking task, it looks like follows. So there are several objects, some of them are highlighted, and after several seconds they begin to move. And your task is to track the the originally highlighted objects, like in this scenario. So um, in this task, we are interested what happens with the tracking when the objects are not simple circles like in the previous presentations, but what happens when the objects are Gabor patches, which might get hidden in a 1 over f noise. So our design, we had 40 trajectories which were the same for all subjects, and we had 4 contrast level for Gabor patches. So we have 160 trials in total. Participants had to click on the targets, so you can see the accuracy in here, that it was something around 3 in the case of the highest visibility, and something slightly above 2 in the case of low visibility. What was interesting that in the condition with low detectability, it took approximately 10 clicks to even find the objects. So maybe the lower accuracy in a low detectability condition was due to the difficulty to even find the objects when they stopped with the movement. So in the second experiment, we follow up this idea and we highlighted in half of the trials the objects, so participants wouldn't have difficulty to find them, while the half of the trials the objects were about the same as in the previous experiment. So we have 3 contrast level in this experiment, and also we added normal MOT task in which the objects were clearly visible, and we have 2 conditions. In half of trials the objects were highlighted, in half of trials they were not. As you can see in the results in here, the accuracy in MOT was higher, almost 4, while in the noise tracking the accuracy was lower. The differences between conditions was significant, and also the differences between highlighting was significant as well, but it's important to say that the difference was small from the practical perspective, and also on the individual level, when we aggregated performance per subject, there's a correlation between accuracy in the noise tracking and the normal MOT tracking, which means that the tracking performance shares some similarity with the normal tracking. Uh, Also, we did very simple experiment in which we measured the intra-individual variances in detecting Gabors in noise. So we had 8 contrast levels, and we found that the variability was kind of low regarding the differences between subjects. And also we studied whether there can be systematic differences due to the differences in MOT trajectories, which we found that they are, and it kind of makes sense in terms that easier tasks are the ones where the objects are clearly separate from each other, or when the targets are very close to each other. So here are the conclusions. Basically, it was more difficult to find objects in noise and track them. And what was interesting, that the tracking accuracy was similar in the case of MOT and in the case of noise tracking. Thank you very much, and you can follow me on Twitter to ask me questions. I'll be happy to answer them.